So here in this problem, we need to resolve the given rational fraction into partial fractions. So let us begin. Now what we have here is, if we consider the denominator, we have x multiplied to x cubed plus 1. So at first glance, it looks like there are only two factors, the first factor being x and the other factor being x cubed plus 1. But what we'll do, we'll try to further factorize x cubed plus 1. Now what we can do here is use the sum of cubes. We know that a cube plus b cube, so that's equals to a plus b multiplied to a squared minus ab plus b squared. So similarly, we can factorize x cubed plus 1 as x plus 1 multiplied to x squared minus x plus 1. So now instead of 2, we have three factors. We have x, x plus 1, and x squared minus x plus 1. Now here, x and x plus 1, these are linear factors, but x squared minus x plus 1 is a quadratic factor. The original rational fraction 1 over x times x cubed plus 1. So we can also rewrite it as 1 over x times x plus 1 multiplied to x squared minus x plus 1. Now what we can do, we can split it into a three partial fraction because we have three factors. The first one will be a over x, followed by b over x plus 1, plus it won't be c over x squared minus x plus 1. We have to be very careful for the numerator, because x squared minus x plus 1 being a quadratic factor, we'll have to choose cx plus d. Now our goal will be to obtain the value of a, b, c, and d. So let us begin. What we'll do, we'll take the entire equation number 1, and we're going to multiply throughout with x times x plus 1 times x squared minus x plus 1, such that we get 1. So this will be the value on the left hand side, and this will be equals to x plus 1 multiplied to x squared minus x plus 1 times a. Next we have x multiplied to x squared minus x plus 1 multiplied to b. And then we have x times x plus 1 multiplied to cx plus d, which will be, now on the next step, what we'll do, we will try to combine all the like terms. So the highest power of x will be x cubed. So x cubed will have a coefficient a plus b plus c, followed by the next lower power of x, which is going to be x squared, and it is going to be having a coefficient negative b plus c plus d. But then we have x. The coefficient of x is going to be b plus d. And we are left with one constant, and that's going to be equals to 1. Now, as we can see here, we have four terms on the right hand side. The first term has the term containing x cubed, second term has the term containing x squared, third term contains the x, and the fourth term is a constant. And if we look at the left hand side, we only have one constant term. So what we can do, we can rewrite the left hand side as 0 times x cubed plus 0 times x squared plus 0 times x, such that we have four terms where the first, second, and third are 0. Right. This is done so that we can equate both sides. So on equating both sides, we are going to get a plus b plus c equals to 0. Then we have negative b plus c plus d. So that's the coefficient of x squared on the right hand side. This is going to be equals to 0. And we have b plus d. So that's equals to 0. And the value of a is going to be equals to 1. Fine. So what we can do, we can use, we have four unknown constants, a, b, c, and d. And we have four equations. So what we can do, we can solve these four equations to obtain the value of a, b, c, and d. This I'll be leaving as an exercise for you to try out. So what I'll do, I'll specify the values here. So we get a value. So a, we have already obtained, this value is equals to 1. B comes out to be negative 1/3. The value of c comes out to be negative 2/3. And finally, the value of d, it comes out to be positive 1/3. third. So now that we have the value of a, b, c, and d, what we can do, we can replace this value back in equation number 1, and let's do that. So we will now get, we have 1 over x multiplied to x cubed plus 1. So this will be equals to a over x. So a is 1. So we have 1 over x. Then we have b over x plus 1. So b is negative 1/3. So we have negative 1 divided by 3 times x plus 1. Then we have cx plus d. So c is negative 2/3 and d is positive 1/3. So what we can do? We can rewrite it as negative 1 over 3. So 3 will be multiplied to x squared minus x plus 1. And in the numerator, we are going to have 2x minus 1. So this is how we have successfully resolved the given rational fraction 1 over x times x cubed plus 1 into 3 partial fraction. So the first one is 1 over x. The second partial fraction is 1 over 3 times x plus 1. That's a negative value. Then the third one is negative 2x minus 1 over 3 times x squared minus x plus 1.